Hello, statistics students. This is your favorite math professor, Professor Amlin, and today we are going to learn section 5.3 in your statistics class. Before we do section 5.3, we need to review sections 5.1 and 5.2 so that you can see how these sections relate. In 5.1, we learned the standard normal curve. In the standard normal curve, you have your curve. The mean, the middle, is 0, and the width of each bar is equal to 1. So this is a 1, 2, 3, a -1, a -2, and a -3. And in 5.1, what we did is we found the probability of landing in a certain region, a certain shaded area of this curve. So what we did is we found the probability of landing in a given, we found probability of landing in a given region. In 5.2, we just did normal curves, which look exactly the same. 3 bars up, 3 bars down. But here, the mean can be any number, and the width of each bar, the standard deviation, so the mean can be any number, and the standard deviation can be any number. But again, I gave you these numbers down here, and you found the probability of landing in a given region. That's what we did in 5.1 and 5.2. So for example, we found the probability of landing in that shaded region. So how does this compare with what we're going to learn today? So today, in 5.3, we're still going to have our curves. Same thing, but now I'm going to give you the region. I'm going to give you the probability, and you got to find the z or the x, depending upon if it's standard normal or if it's just normal. So I'm going to give you, given the percent shaded. So I'm going to give you what percentage of the curve is shaded, and you've got to find the x or the z. In 5.1 and 5.2, I gave you the z or the x, and you had to find what the area, the shaded area. Now I'm giving you the shaded area, and you got to find the z or the x. So basically, we're just going backwards. The problem is, these are not as easy to do on the calculator, because your calculator, the calculator can only find areas shaded to the left. So it can only find if you've already been given shaded to the left. But we learned in 5.1 and 5.2 that we can also shade to the right. So what do? So what do you do if shaded to the right? The first thing you need to know if it's shaded to the right, it has a name when it's shaded to the right, and it's named critical value. So when it's shaded to the right, it's called a critical value. And what you're going to do to find the area to the left, you're going to do 1 minus the area to the right. And whenever you have a critical value, you have to do 1 minus the area to the right. And that's how you turn a critical value to the left. And we will be doing some examples of these. I know it makes no sense right now. Just be patient and we'll get some examples. One more thing before we start our lecture notes. The other thing you need to know in your calculator when you go backwards. So in 5.1 and 5.2, we use the button called normal CDF. In 5.3, we're going to use the button called inverse norm, INVNORM. INVNORM, and this is the button that we're going to use in our calculator for section 5.3. So at this time, I'm going to tell you, if you have not already done so, to stop this video, hit pause, go to your My Math Lab, to the announcements below the calendar, and follow the directions on how to print out your lecture notes for 5.3 so that you can follow along. Again, you can't learn math by watching me doing it. You learn math by doing it yourself. Math is not a spectator sport. You actually have to participate in the sport to learn how to play it. So please, if you have not done so, hit pause on this video and go print your 5.3 lecture notes. All right, so here we go. Section 5.3. Normal distributions, finding the values of z and x. So now we're going backwards. Before we found the probability, now we're going to find the values of z and x. In 5.1 and 5.2, you were given the value of z or x and asked to find the probability or area under the normal curve. But what if you're given the probability or area under the curve and you want to find the value for z or x? So in our calculator, we're going to use the inverse norm button, the area to the left, the mean, and the standard deviation. But what if the area or probability is shaded to the right? This is called a critical value, and the following process must be used. So the first thing you're going to do is you're going to do 1 minus the area to the right, and then you're going to put it in this inverse norm button. So here we go. Example 1. Find the z-score. So I want to find the z. So here's my curve. I'm looking for the z that corresponds to a cumulative area of 0.3632, which means 36.32% of the curve is shaded. Now, remember in 5.1 and 5.2 that if no direction is given, we assume it's being shaded to the left. So 36.32% of this curve is shaded. 0.3632 of this curve is shaded. And I want to find the z that goes with that. So here we go. Step 1, turn on your calculator. All right, go to second dister and look at number 3 where it says inverse norm. You ready? Area. The area that's being shaded is 0.3632. The mean is 0. And the standard deviation is 1. How do I know that the mean is 0 and the standard deviation is 1? Because it's asking me to find z. And remember on z is standard normal with a mean of 0 and a standard deviation of 1. And it's shaded to the left. So I'm going to hit paste. I'm going to hit enter. And my z, usually z-scores are written to 2 decimal places, usually. Make sure when you do your homework on My Math Lab, you read the little fine blue print of what to round to. And if I'm going to round this to 2 decimal places, it would be negative 0.35. And there is your answer to the first one. All right, so here we go. Next one. Find the z-score. Okay. That has 10.75% of the distribution's area to its right. So that means 10.75% of this curve is shaded to the right, and I want to find the z that goes along with this. But we got a problem. This is called critical value because it's shaded to the right. So what you have to do is you have to do 1 minus 0.1075. 1, 2. This gives you, hold on, 1 minus 0.1075 is 0.8925. But we're not done. That's not z. That's the critical value. Now you're going to go to second dister number 3. My area is 0.8925. The mean is 0. The standard deviation was 1. We're going to the left. You always want it to the left. Hit paste, hit enter, and our answer is Z equals, and if I round that to 2 decimal places, I get Z equals 1.24. Now, what I learned, timeout, from uploading the first video is that it's very difficult to upload videos to YouTube that are longer than 15 minutes. So what I'm going to do right now is I'm going to stop this video, but don't worry, I'm going to create a second video with the second half of the packet in it. So be patient, give me a second to re-upload another video, and I'll be with you in just a minute.